Um, let's do a division. So let's divide a couple rational expressions. A couple things. So this is going to have the kind of keep, change, flip stuff, right? Again, that's kind of a over b. Divide by c over d as kind of a generic fraction becomes a over b times, flip it, d over c. That's kind of our setup. Now, however, before we do that, we need to find our restrictions. So the restrictions are, again, they just don't go away. They're your annoying young sibling who's sort of following you everywhere and trying to sort of tag along, and you just can't shake them. I love my sister. She's great. I never had this experience at all. In any event, so we're not allowed to divide by 0. So that means any denominators, so in this case, right, kind of obviously 3x minus 9, x minus 3, both of those we need to sort of do restrictions on, right? So 3x minus 9 is not allowed to be 0. This is an interesting one. This essentially is, if we factor, this would be 3 comes out, and then this is kind of x minus 3 is not allowed to be 0. Actually, I'm glad we've done this. X minus 3, that would mean that x is not allowed to be positive 3. You might say, well, what about the 3 in front here? And so the restriction, right, the idea is that 3 is not allowed to be 0. And to which I would say, okay, sounds good. 3 is not 0. That's kind of always true. So restrictions, kind of by definition, are based on x values. So if you just have a constant 3 or any other constant in front of your polynomial, you're not going to get any restrictions from it, because a constant is never going to just like become a 0 for no reason, right? It already is some other non-zero number, kind of by definition of just how numbers work. So if we get this 3 in front, it doesn't give us an extra 3 as a restriction. It doesn't get us anything. So this just is its own thing. 3 needs to not be 0. It's not, so that's great. That's always true. X cannot be 3 based on the x minus 3, right? It's not allowed to be 0. So okay, so that one we got to check. If we go over here, you say, okay, so this is just x minus 3 is not 0. That's actually the same thing we had on this side, so that just sort of reaffirms that x is not allowed to be positive 3. So those are all like, quote unquote, like two denominators, right? Here and here. Well, kind of, sort of, in some sense, yes, those are the denominators of the two fractions that we're working with. However, we also have to consider the numerator of the second fraction. So this, in this case, x squared minus 4, is also not allowed to be 0. And the reason there, right, if we sort of think of this, well, you can justify it a couple ways. So this is kind of in the c position. So once I do my sort of keep, change, flip, and I sort of take the reciprocal of the second, so now c is in the denominator, right? So certainly from that sense, c is not allowed to be 0. Now you might say, well, okay, so then isn't d okay to be 0? And the answer is, well, no, because d is a denominator here, right? So in this case, d is not allowed to be 0 from this, and of course b is also not allowed to be 0. So you actually end up with, 3 out of your 4 kind of polynomials, 3 out of your 4 positions here give you these restrictions. Which is kind of interesting. The only place where it's like, quote unquote, safe to hit 0 is in the top left, and kind of what would be our sort of A position in our generic version. So x squared minus 4 also needs to be factored. I can't remember, we may have done this exact one in another video. This again is our nice difference of squares, right? There is no middle term, and you have, of course, 4 would be 2 squared. This is going to get you 2 restrictions. X cannot be negative 2 or positive 2, right? You get negative 2 from the x plus 2. You'll get x cannot be positive 2 from the x minus 2. So we have sort of 3 different positions. We've gotten kind of one, x cannot be 3. That sort of showed up twice. So that's kind of one number, and then, number 2 and number 3 here. Great. So, okay. that's all of our restrictions, so that's cool. What do we need to do to actually like do the division here and like solve this problem? So let's kind of rewrite it for a second. X squared plus 3x plus 2 over 3x minus 9, right? And then it's divided by x squared minus 4 over x minus 3. Let me shift this up so you can actually see what we're working with. So the move here, of course, is to rewrite it. So x squared plus 3x plus 2. So keep the first one the same, 3x minus 9. We'll insert all of our factored versions here in a second. Times, so flip the second one, right? So now x minus 3 is up top, and your x squared minus 4 is in the denominator, right? So you've done the sort of keep, change, flip, kept the first one, changed from division to multiplication. You flipped that second fraction. The one thing we didn't do is we do need to factor x squared plus 3x plus 2. So let's take a second and do that. This, right? A is 1, B is 3, C is 2. It looks like this, right? A times C, we have this nice A equals 1. A times C, 1 times 2 is 2. We need to add to the B value, which is 3. Really only one option to get a 2. It has to be either, sort of positive 1 and 2 or double negative 1 and 2. And if we add them and get a positive, it's got to be positive and positive, right? So positive 1 and positive 2 gets me to 3. So that means the factoring here is going to look like x plus 1 times x plus 2. So then all of this together, so up top is my x plus 1 and my x plus 2, right? That's my sort of top left in the kind of A position. 3x minus 9, we did that a second ago. We said that would just be 3 times x minus 3. So that's there, times, here's my x minus 3. I'll throw that in parentheses. Again, kind of somewhat unsuspiciously, we're getting some overlap here, the x minus 3 and the x minus 3. One way to kind of anticipate that and know that it was coming is when we did the restrictions. You had the same, right? X cannot be 3, x cannot be 3. If you have matching restrictions, that means they're sort of coming from matching polynomials, matching factors. So you can kind of expect to see the same things there. What was the bottom one? X squared minus 4. So that was our x plus 2, x minus 2. These are sort of complex enough problems in some sense, right? There's enough steps here that how you organize it is sort of your own call. I'm trying to keep it as organized as I can, but you have to juggle a few different things kind of all at once. You're doing factoring, you're doing these restrictions, you're flipping stuff, you're sort of changing your operations, you're moving everything around. So whatever kind of order that you're using to kind of keep this organized is fine, as long as it works for you. So for me, I've got everything rewritten here, and so now I'm going to look to cancel any sort of common factors from the top and the bottom. So x plus 2 is showing up here and here. We said the x minus 3, kind of as expected, was showing up here and here. Sometimes what I like to do is even just rewrite it. So this would be what? X plus 1 in my numerator. The other 2 are gone over, so 3 times x minus 2. So sometimes what I like to do is even just like take a second and kind of rewrite it halfway through, just to see and give myself sort of a new line to kind of look at this again, to look for anything else that's overlapping. In this case, there isn't, right? X plus 1, x minus 2, neither of those are the same. And of course, 3 is its own number and it doesn't have a matching 3 to go with it, so that would be fine. So this is going to be our answer, right? I mean, it's kind of weird in the same way that fraction, multiplication, and division, sometimes you're just reducing and you kind of just get an answer and it feels like you didn't even multiply at all. That's kind of what's happening here, right? I mean, I guess I'm sort of not writing it where you would say x plus 1 over 3 times 1 over x minus 2. I'm sort of jumping over that step. But in theory, you could include it. It's not necessary, though. So it's this guy where, so what were our restrictions? X cannot be equal to, let's pull them back. So positive 3 and then negative or positive 2. 3, negative 2 or positive 2. So again, always, always, always get those restrictions on there. The homework will get you every time, and of course then your quiz problems will sort of get you as well. Every time with those restrictions, it's easy to kind of forget and leave them off, and then all of a sudden you've lost your points when you really didn't need to. In any event, that's division. That's the basic form of it. It's pretty much just you know, a hop and a skip and a jump away from a multiplication problem. So in the same way that just it would work with regular fractions, we have the same kind of setups here, and you get, you know, similar kind of results. Everything here is just expanded, and you have these additional restrictions to look for because we're doing polynomials. That's the idea.